Good day, mates. For today's segment, we're going to discuss about scientific measurement techniques. A key component of most scientific investigations is measurement. By using a common system of units of measurement and by making precise and accurate measurements, scientists ensure that procedures and results can be reported and repeated anywhere in the world. The two systems of measurement used by scientists are the English system and the metric system. However, as you're probably aware, most scientific data is reported in metric units. Measurements are made using an instrument marked and/or pre-programmed in standard units, mechanical balance, plus URH with variations, and a device that can be manually set to deliver a specific volume. Throughout the student's undergraduate career, you will be asked numerous times to measure the length, mass, and volume of an object. Thus, familiarity with devices routinely used to measure mass and volume are essential for the successful completion of a number of laboratory exercises. Length may be measured with a metric ruler using SI units such as millimeters and centimeters. Scientists measure mass with mechanical or electronic balances, and the method is straightforward. Various devices are available for the measurement of volume. These include various kinds of pipettes, graduated cylinders, and volumetric glasses. It is important to know which device is most appropriate for a given situation. Your efficiency, accuracy, and precision in making such measurement will improve as you gain experience. Length measurement. A meter scale is used for lengths from 1 mm to 100 meter. A Vernier Caliper is used for lengths to an accuracy of 0.1 mm. A screw gauge and an spirometer can be used to measure lengths as small as 0.01 mm. To measure lengths beyond these ranges, make use of some special indirect methods. Measuring length using a ruler. Use the unit in which you want to measure length. If you want a value in centimeters, then take the centimeters side of the ruler. If in inches, then take the inches side of the ruler. Place object beside the ruler starting from point 0 on it. Look at the end point and mark the value. Reminders on measuring length. It is important to convert different units of length into one before solving the questions. Meter is also called the SI unit of length or base unit of length.
For the second measurement technique, let's proceed with the measurement of mass. The measurement of mass in the laboratory is performed using balances. For most everyday objects, scientists use a balance to obtain an object's mass. A balance compares an object with a known mass to the object in question. The common balances utilized in the lab are the single, double, triple, and 4-beam or centigram balances. Analytical balances are used to weigh defined amounts of substances. The standard unit of measure for mass is based on the metric system and is typically denoted as kilograms or grams. In order to protect the balances and ensure accurate results, a number of rules should be followed. Always check that the balance is level before using it. Never weigh directly on the balance pan. Always use a piece of weighing paper or weighing vessels to protect it. Do not weigh hot or cold objects. Clean up any spills around the balance immediately. There are two ways of measuring mass: direct and indirect weighing, also called weighing by difference. Direct weighing means that an object is placed directly on a balance and the mass is weighed. Weighing directly requires that the balance be carefully zeroed in order to obtain accurate results. The second way is weighing by difference. Weighing by difference requires that two measurements be taken. These measurements can be taken in one of two ways. A clean piece of weighing paper or weighing vessel is placed on the balance and weighed. This is the first reading. The substance to be weighed out is then placed on the weighing paper and weighed. This is the second reading. The mass of the substance is determined by subtracting the first reading from the second reading. Second, a container holding the substance of interest is placed on the balance and weighed. This is the first reading. The substance to be used is removed from the container and the container weighed again. This is the second reading. The mass of substance taken is determined by subtracting the second reading from the first. When weighing by difference, an exact zeroing of the balance is not required because any error in initial reading will cancel when subtraction of the readings occurs. However, it is always good practice to zero the balance when you begin to be certain it is working correctly. In the absence of any weighing vessel for solid substances, you can improvise by making a weighing paper. To do this, get a small sheet of clean paper, fold the paper into half, then make a quiz. Fold the top half into the middle and make a quiz. Same goes with the bottom half. Fold it towards the middle and make a quiz. Make a small triangle folds in two corners of the paper. Fold the top and bottom part outward. Fold the side with small folded triangles inward and make a quiz. Open the folded sides. Leave the other side open to facilitate easier transfer of solid chemicals. A common step that is observed when weighing in electronic balances is tailoring. By tailoring a balance, the process of weighing by difference is done automatically. When a balance is paired with an object on the balance pan, the weight of the object will be automatically subtracted from every reading until the balance is repaired or zeroed. A weighing paper is placed on the balance pan and the tare button is pushed. Zero should appear on the display. If a substance is now added to the weighing paper, only the mass of the substance is displayed. Tailoring is a very convenient method of weighing out chemicals, one you will probably use quite a lot.
For the next measuring technique, we will focus on the volume measurement of liquids. Volume can mean how much space something takes up. In the laboratory, the tools for measuring the volume of liquids are generally made from glass, plastic, or occasionally metal, although scientists refer to all of them as glasswares. Scientists and chemists in particular have a variety of glasswares at their disposal for measuring volumes. The particular piece of glassware chosen in any situation will depend primarily upon two factors: the required volume and the accuracy required for the measurement. The following are some of the tools used to measure volumes of liquid. Beaker, our least accurate instrument for measuring volumes. Graduated cylinders, volumetric flask, used to measure a single predetermined volume. Early layer flask, used to measure approximate volumes, mixing, and sample storage. Pipettes, used to measure a volume of liquid that is being transferred to another container. Pipettes are usually used to measure liquid volumes of 10 ml or less, although larger pipes are available. Pipette comes in two types, usually to deliver, labeled TD, and to contain, usually labeled TC. A label near the upper end of the pipette shaft indicates the type of pipette. Most pipette that you will work with will be the TD type. The measured volume corresponds to the volume of liquid contained in the cylinder. Hence, the graduated cylinder and glasswares like volumetric flask, earthenware flask, and beaker are classified as the contained glasswares. The volume of liquid in a graduated cylinder is obtained directly by reading the calibrated scale. In most situations, the liquid will be water on an aqueous solution. If the cylinder is made from the glass, the liquid surface is curved or U-shaped rather than horizontal due to the relatively strong attractive force between water and the glass. The curved shape is called the meniscus. As a general rule, the bottom of the meniscus is taken as the liquid level in a glass cylinder or any other volume measuring device made from glass. If the cylinder is made from plastic, the liquid surface is flat or horizontal. There is no meniscus.